we're finding out some net ionizations. Alright, y'all ready for this? Get ready. We're going to start off with symmetry. Actually, this is the only one we'll be doing for this video. We're going to do 3 pHs. pH 4, 7, and 11. Before we start, remember a couple of things. When pKa is bigger than pH, what happens? It protonates. There we go. Now, we're going to start off with S for 4. 4. Actually, no. That's the wrong way of teaching it. Before you do the letters, first do determinuses. The N terminus is the beginning terminus, and the N terminus is the C terminus. So if we look on this little sheet I put up here, the N terminus pKa is 8, and it's bigger than the pH 4. So 8 bigger than 4, and it protonates. For the N terminus, if you look at it on any of these, it's that little NH3 plus group, right? And for those, when it protonates, it's just a +1. Now we look at the pKa for the C terminus. pKa is, in fact, 3.7 and smaller than the pH. So, what is it? It is deprotonated. And for the carboxyl group, what happens is it is a negative. Now, before I continue any longer, I want to go into detail for this for just a minute or two. You guys got to look at the structures and see, for example, NH3 can protonate into what? Nothing. It's already protonated to the max. So when it protonates, it just becomes a +1. But if it deprotonates, this is a different story, and it becomes NH2. Thus, what is the charge on it? A 0. Now, if we look at the carboxyl, if it protonates, it gains an H, and it becomes a 0 because the negative is taken out. But if it wants to deprotonate, it can't really. Deprotonate already has, so it just gets a negative charge. Understand that and apply it to the future amino acids that we're going to look at along this video. Let's look at S. Looking at S, serine. What is the pKa for serine? 13. 13 is bigger than 4. What does it do? It protonates. There we go. Then we got to look at the group a little bit. If we're looking at this group, there's an alcohol, right? The alcohol, it can lose one when it deprotonates, becoming an OH, or a negative oxygen. But if it wants to protonate, it just stays at 0. Why? Because OH is already the protonated version. At least that's how I like to think about it. So for S, 13 is bigger than 4. What does that mean? Oh, I read that earlier. Sorry. It means it's just a 0. Because what? The OH, when it's protonated, 0. Because it doesn't want, or it can't take any more H's. Let's look at M. And remember, there's 2 of M. For M, where's M? Where's M? What is M? M. Methion, or something meth. I don't know, meth. Look at this one. We see that what? It doesn't have a pKa. What does that mean? No pKa equals neutral. At least for this course and scenario. Yay! So what do we put there? No matter what, if it protonates, deprotonates, doesn't have a pK, so we don't know. And if you look at the structure, even we see that it's a CH3, and carbon is already attaching to the thing itself right here, or right here. And then it already has 3 H's attaching, so boom, it's already happy. It doesn't want any more. It doesn't need any more. So super stable. Boom. 2 zeros. I love that. I love zeros. My favorite thing in the world. Go to E. Glutamate. pK is 4.3. It is also, oopsie, is also bigger than 4. So it protonates. Now in this scenario, the side group is just what? It's just a carboxyl group. And what does that mean? If it protonates for a carboxyl group, what is the answer? It is a 0. Boom, another 0 in the books. It's getting easy, isn't it? Threonine or whatever that says, blah, blah. We see that OH group, right? And the pK is 13. So, 13 bigger than 4. I know my 4s look like 9s. Don't judge me. What does that mean? It means that it's just going to be a 0. Because of this whole thing I told you earlier. 0. Let's look at R. Arginine. This one's a little complicated. You might say, like, oh, look at this thing. It's balanced. But don't worry about that. Look at the thing that's unbalanced. That's what we look for. Look at the unbalanced thing in the side chains. That's how I like to remember it. And what's unbalanced here? This weird NH2. And what can it do? Just like this one over here. Or wait, sorry. It has a positive on it, right? So just like this one over here with a positive on it. If it wants to, it can protonate into a +1. But it's already has a +1. So if it protonates, it's just going to be plus. And if it deprotonates, it's just going to revert to the NH2. So for this one, the pK is 12.3. Bigger than, oh, that's really bad. Bigger than 4. And what does that mean? It protonates into a +1. The R right there. Now if we look at the Y, what is the Y? What is the Y? Tyrosine. Tyrosine, we see that OH right there. Oh, I keep doing reverse. OH right there. Right? What do we know about OHs? If it protonates, which it will in this scenario, 9.8, bigger than 4, protonates, and it just becomes a 0. So let's see what the overall net charge is in this scenario. +1, -1, cancel. One more. The overall net charge is just +1. Let's do a little faster for pH 7. Okay. N equals +1. Oh, sorry, too fast. The N, right? The N, the pK is 8, bigger than 7. What does it do? Protonates into a +1. Same thing. Remember, NH3s protonates into +1 because it already has a plus and it can't gain any more, right? If it deprotonates, however, which you can do, it becomes 0. Protonates, perfect. Now the carbon, again, deprotonates, and same thing, same scenario. It can gain 1, become a COOH, which has a charge of 0 through protonation, or it can not lose anything because it can't even deprotonate anymore than it already has, and just be a -1. Boom. Let's look at S. Serine, pK 13, right? 13 bigger than 7, and we can look from earlier, or just look at the structure again. It has that OH, which we look right here. What happens when it's protonated, right? By the way, this is oxygen. This isn't oxygen. I think I'm Xing right now. But this is negative oxygen. This is just a 0. No difference in my writing, please. I'll identify it whenever I can. So it's just a 0. Let's look at the M's. Oh, what do you remember the M's again? There is nothing on there. So it's just a neutral one. Don't matter what the pK is. And if you look at it, what I said earlier about the CH3s, see, already it has 4. It doesn't need any more. Boom, 0, 0. Let's look at the E's. Glutamate. It has that carboxyl group. What do we say with the carboxyl group? If it protonates, which it will. Oh, whoa. It don't pronate here. It don't pronate. It actually deprotonates. So what is it? It's a -1. Love that. Actually, I don't like as much zeros, but it's fine. Threonine, same scenario. Oh, not the same scenario. It's an alcohol, though. Similar scenario. Look at the alcohol one more time. Look at it. Look at it. I love alcohol because you know what's going to happen to it. Boom. I also love alcohol, by the way. Sometimes. But anyways, what's going to happen if it protonates, which it will in the scenario? Boom, boom. It will be a 0, which I love as well. Let's look at the R. I'm guessing it's probably going to protonate. Am I right or am I right? Yes, it will, because it has a 12.3, which is so much bigger than the 7. And boom, it's going to have a +1, because this one is, there's NH2 plus on it, which can gain an H plus and become another NH3 plus. And then if it loses an H, it becomes this weird NH group. But whatever. It becomes 0 if it loses an H. Just remember that. And then what we're gonna do is we're gonna do Y, the very last one. Y. Tyrosine, an OH group. One last time, take a look at the OH group. What is it? It's gonna be protonated 2. 9.8 is bigger than 7, and it's gonna be 0. Add all these up. These two cancel up top, and oh, it's just 0. Love that. Let's look over here a little bit. We lost some space. Some big writer. Last time, let's look at the N first. This is for pH 11, by the way. pH 11. Oh, for the first time, the N is actually 0 because pH 11 is bigger. Thus, it deprotonates. Carboxyl, same thing as always because it's just so weak. Deprotonate to -1. Look at the S. Serine. 13 still protonates into a 0 because of its OH group. Look at the Y. Tyrosine. Oh, tyrosine. Did I do earlier right? Yeah, I did. Oh, there's 2. I could have just done ×2 eyes doing extra work. Oh my god. There's 2 eyes actually. I don't want to do that work. They're both gonna be. Oh, this time they're actually smaller. So 9.8, and it's -1 times 2 becomes -2. Because 9.8 is smaller than 11, thus it deprotonates into its -O form. And then we're gonna go through M's, and guess what? They're always neutral, which we love, equals 0. And then we look at the T's, which are really nice as well. The theorines, there's an OH on them. 13, bigger than 11. Love that. It's a 0 as well. Then we're gonna look at the R's, arginines, and there's the NH2, that weird NH2, right? But we can remember it. Just like keep remembering this. It's just the NH2 plus, and it can protonate and gain 1, and it'll still be a plus. And if it loses an H, it's just gonna be an NH, which is gonna be neutral, right? That's how NHs are. You know how they are. Because like NH is like if it loses one, by the way, there is logic behind it. It has 2 bonds, right? And the structure of a N is like this. So it has 2 bonds and it has an H attached to it. So it's actually perfectly happy like that, right? But it's not happy when it has this. So that's why it's a plus. That's why if it gains one, an H, it'll be NH3 and it'll be like resonance, but that's like a whole different thing. We don't talk about that right now. Sorry. 12.3 is bigger than 11. Boom. Benito. Oh wait, did we do the R? Arginine. Yeah, that's what we're doing. Okay, there we go. Big 11. Boom. +1. Love it. Then we're going to move on into the Y. Oh, we did the Y's. Okay, that's it. So that'll be -1 and then a -2. That's it, guys. Tell me if you guys have any questions. If you can't read my writing, misunderstand something, shoot me a text. I did the best I could to explain it. It definitely is a really tricky process, but yeah, that's about it. Please like and subscribe, and let me know what else you guys need help on. Thank you.